Hey everyone, so in this PowerPoint we're going to go over scheduling with independent tasks and we're going to talk about what that means. So an independent task, if you remember from the last section, is a task that we don't have anything that precedes it. So unfortunately there are no effective optimal algorithms known for scheduling even when all the tasks are independent, so we kind of just have to move them around until it works. So in this situation, it does make it a little bit easier though, because with independent tasks, we don't have to do something before we do something else. So like in the example we had with baking a cake, we really can't do anything until we've done the step before it. So let's just say we have a whole bunch of homework assignments to do in different classes, and we can do any of those homework assignments first, and they each have a set amount of time that we have to do them. We just have to get them all done. So that would be an example of an independent task. So with this, we're going to assign the task to processors when they become free. So it doesn't matter which one they do first. It just matters that we're going to give it to them to do one of them. The second thing we're going to have is without precedence relations, we're going to have the critical path time. We're going to go a little bit more into detail about critical path time when we get into the later sections. Section 3 and 4 is going to talk about decreasing time and critical path time. So this is going to be the same as our processing time. So for now, we're just going to talk about processing time, but it will relate later when we get into that section. So this means that the critical time and the decreasing, they're all going to be exactly the same. That's why we're going to start with this, and it's very simple to work with. We're also going to calculate the relative error of all of our algorithms we're going to learn based on this independent task algorithm. So the independent task scheduling is basically, we're going to find the quickest way that we could possibly get it done. And remember, we abbreviated that with optimal, whereas FIN is the actual finishing time when we just kind of assigned random things to them. Our ideal is to try to get this to 0%. If it's 0, that means it's optimal and it's perfect. That's the quickest we could get. But you'll see in some of the algorithms we do, we're not going to get 0%. We're going to have a lot more relative error. So now we're going to talk about actually scheduling with priority list. What does priority mean? So priority means that we have to do something before we do something else. So priority list is saying, okay, what is number one priority for us to get done? We're going to take all of the tasks and list them in prioritized order, in the order we want to execute them first. So let's say we have a couple of homework assignments. We have math, we have English, and then we have art. We have a really good grade in art, but we're maybe struggling in math and English, so we want to prioritize those so we at least get math and English done before we start working on the fun art project. So if task X comes before Y in the priority list, that means that we want to do X before we do Y if it's possible to do. Now, what happens if we have to do our art project before we do our math project for some reason? Then that means we can't do that one yet. We have to wait until it's eligible, and then we're going to select the one that comes first in our priority list. So the number of priority lists that are possible if we have M tasks, so let's say we have 3 homework assignments, there's going to be M factorial. M factorial just means we're going to do M times M minus 1 times M minus 2 times M minus 3, so forth and so on until we get times 1. So we're going to multiply that number by everything below it. So for example, if we have M equals 3 homework assignments, then we're going to do 3 times 2 times 1, which will give us 6 possible priority lists that we could come up with. So we're going to use this table that we learned about in the last chapter. It has our timeline. So the process of scheduling tasks using a priority list, we're going to use the priority list model. So we're going to use that priority list that we've created of what we want to get done first, and that's going to tell us which one we're going to select. So let's look a little bit more into that with an example. So at any particular moment in time throughout a project, a processor is either going to be busy, idle, or ineligible, ready, or in execution. So we had this terminology and this notation that we talked about when we first went over the idea of priority list. and scheduling. So when something is ineligible, we're not going to circle it. We're not going to do anything. We're going to just leave it as the letter. When it's ready to be processed, we're going to circle it. So we circle it, and then once we start working on it, we're going to cross through it. And then once we've finished it, we're going to do that second cross through it so we've X'd it out. So we know where we're at in our process and we don't get confused and forget where we're working. So let's try an example. So if our priority list is A, B, C, D, and E, meaning we want to get A done first. So this is our first priority and this is our last priority. So ideally, this is how we want to do our task. But as you can see, we can't do some of these until we finish the ones before. So we can't do D until we've done B, D until we've done A, so forth and so on. So let's assign this with N equals 2. That means we have 2 processors. Well, first thing we need to do is figure out which ones of these are eligible. If we're starting, we can't do D or E or N. A, B, and C are all eligible. So we're going to circle those and leave the other ones blank right now. All right, we're going to start and look at our priority list. The first thing we want to try to complete is A. So we're going to assign A to processor 1. Well, A is 6 units long. So we're going to come right here and we're going to assign A. Since we've assigned it, we're going to put 1 line through it until we're working through it. So now we're moving along. All right, processor 2 now needs something to do. Well, we have B and C available. Well, we've already done A, so now we're going to move along. We want to go ahead and do B. So we're going to cross through B. We're going to assign B right here. So processor 2 starts working on task B. Once task B has already gone along, we're going to go and go and go, and then we finish with task B. Now we finish with task B, we need to assign something else to processor 2. So we're going to cross out task B. We can't circle D yet because we have to finish A and B. So the only thing that's left is C. So we're going to assign C here. And C is going to be 7. All right, let's move C right here. We're going to start working on C. We're going to move along. And now we're right here at 6 units of time. We finish A, so let's cross through A. Now A and B are finished, so we can circle D. Well, let's go ahead. That's the only thing we can work on. So we're going to go ahead and assign D right here. D is only 2 units of time. All right, we're going to move along. Then we actually finish D. Once we finish D, so we started D, and then we finished D. All right, we can't circle the end and we can't circle E because we got to wait until C is finished. So this right here is just going to be kind of blank time. So we're going to move along. We're going to keep going until we finish C. So now we're right here and we finish C. When we finish C, we can circle E. So E is eligible. We can assign it to whichever processor we want to. Let's just assign it to processor 1, and that is 5 units of time. All right, we're going to move along. We started E. We finished E. When we get down here, and now we're at our end, so we can stop. And our finishing time is 17. Now, if you notice, this little spot right here and this little spot right here, this processor wasn't doing anything. Processor 1 was waiting on processor 2 to finish C before we could start on E. And then once they started on E, processor 2 was stuck doing nothing. So we called this right here, this is our idle time. All right, and then our finishing time was 17, which is where we're at right here at the end. So our idle time, when we add that up, we had 2, 4, 6, 8, 9. Idle time of 9 units of time, and our finishing time was 17. All right, now let's try a different one. So it's the same examples or the same graph. We have a couple different numbers plugged in and a different priority list. So we're going to have 2 processors again. First thing we're going to do is circle the ones that are eligible. We're going to move a little faster in this example. And we're going to go based off of our priority list. So we want to do E first. Well, we can't do E, so we're going to move on. Can we do D? No. Can we do C? Yes. So we're going to assign C, which is 7 units of time. All right, we started it, so we're going to put 1 line through it. All right, processor 2 needs to do something, so we're either going to do B or A. B comes first, so we're going to start with B. And B is 5 units of time. All right, now we move along, we get right here and we finish B. Well, we can't circle D yet or E, so the only thing we can work on is A. A is 6 units of time. So we're going to put A right here. So now we're working on A, we move along and we finish C. So we started A, we finished C. And now that we finished C, we can start circling E because that one now becomes eligible. We're still not ready to do D yet. So now we can put E right here, which is 5. All right, and we move along, we move along. We're right here, we finish A, we started E, we finished A. All right, now that we finished A, we're still working on E, but we can circle D. Well, D's ready, so let's go ahead and put D right here. We're going to start working on D. We're going to move along. Okay, now we finish E, but we can't move on to the end until we finish D. All right, once we finish D, we move on to our end and we're done. Our total finishing time is 13, and we have some idle time right here, so our idle time is only 1. Now let's try it again, but now we're going to have 3 processors instead of just 2. So it's a little bit trickier, but it can be a little bit quicker because we have 3 people working on it. So we're going to take our priority list and we're going to circle on our graph, our project digraph. We're going to circle the ones that are eligible, just like before. The first processor wants to work on one of these. Well, which one does it want to work on? Well, we start E, D, now C. Okay, so we're going to write C right here. So processor 1 is going to start working on C. Processor 2 is going to work on either B or A. Well, we want it to work on B because that comes first. So B is 5. And then processor 3 wants to work on the only thing that's left. So we're going to start processor 3 with A, which is 6 units of time. All right, now we're going to move on, and we're going to move until we finish B. So now B's finished, but we can't circle anything else. So we really can't do anything. We got to keep moving. All right, now we finish A. So A and B are finished, so we can circle D. One of these processors is going to start working on D, so let's put D right here. So from here to here is D. We start working on D, we move along. All right, now we have finished C. We can circle E because E is now eligible. All right, who's going to work on E? It really doesn't matter. Let's just assign E, which is 5. All right, we assign this right here. There's no gap there. And remember, there's a little bit of a gap right here. So let's go ahead and highlight that so we don't forget it. All right, and then we move along. We started on E. There's nothing else for processor 3 to work on. So all of this right here is idle time. And then D can't work on anything else either, or processor 2 can't work on anything else either because we got to wait until once D's finished, it kind of just sits there. And then we have to wait for E to finish. Once E's finished, we're right here at the end. We can circle it. So we have some more idle time right here. So now if we look at our total finishing time is 12. And our idle time is, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Our idle time is 11 units of time or 11 hours, whatever we're working with. Now let's do it again with 3, but this time we're given a table. So the first thing we need to do when we're given a table is we need to write our project diagram so it makes it a little bit easier. So remember, we start right here and starting time is 0. We're going to go to all of the ones that don't have any precedence relations first. So we have A, B, and C. So let's write A, B, and C. A takes 3 units of time. B takes 4 units of time. And C takes 7 units of time. All right, now let's look at what we need to do A to get to somewhere else. All right, we have to do A before we do D. So let's write D right here with 6. Let's draw our arrow. We also have to do B before we do D, so let's draw our arrow from B to D. All right, then we need to do B before we do E, so let's write our E right here. E is 5. And we need to do D before we do F, so let's write our F right here. F is 5, so D before F, and E before F also, so let's draw that. And then lastly, we have E before G. So let's write our G right here. G is 4 units of time. All right, and then we can go to our end. End is 0. All right, I'm going to actually write end here. Let's erase that since we already have an E. All right, and then end has a time of 0. And we go from all of these to the end. So now let's switch back our color, and we're going to actually assign this with 3 processors. So our priority list is going to be given. So in this one, we actually aren't given our priority list. So let's assume our priority list is A, B, C, D, E, F, G. We're going to assume that you will always be given your priority list when you're given an example. So our priority list, we want to do A first, then B, then C, then D, so forth and so on. So we're going to have A is ready, B is ready, and C is ready. Which one do we want to do first? Well, we want to assign A, which is 3 units of time. So we're going to put an A right here. All right, then we're going to want to cross that out because we started it. The second processor is going to start working on B. So B is 4. So let's write our B right here. Started working on it, so we're going to cross it out once. And then C is the last one we're going to want to start working on. So C is 7 units of time. So let's write C right here. We're going to move along until we finish A. Oh, we've already started C. We finish A. Once we finish A, we can't do D yet because we got to finish B. So we're just going to sit there and we're going to move along. All right, now we finished B. Now we can circle D and circle E. So this right here is some idle time that we had. So we could either start on D or E. We want to start D first. So D is 6. So we're going to write our D right here. And then we do E for 5. E right here. We're going to move along. We've started both of these. And now we finish C. So we're right here. We finished C. Well, we can't circle the end yet, so we're going to have to move along. Well, there's nothing else that we can do because nothing else is done yet, so we're going to have to keep moving along. Then we finish E. If we finish E, we can circle G, but not F. So now we're sitting here with processor 2 needs something to do, or processor 3. So let's assign G, which is 4. All right, so we start on G while we're waiting. All right, now we finish D. And now we can circle F, so somebody can work on F. So let's write F right here. All right, F is 5 units long. So we move along, we've started F, we finish G right here. Well, there's nothing else we can do yet, so we're just going to keep waiting. Now we finish F. We're finished with all of those, so we can finish. This is our finish time right here of 15. So we're going to write fin equals 15. This is idle time, and all of this down here is also idle time. So we have a lot of idle time in this example. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 units of time for our idle time. All right, so now let's move on to our last example. We're going to also create our priority list or create our diagraph, and then we're going to assume our priority list again is A, B, C, D, E, F, G. Again, you will always be given your priority list if you're asked to create a priority list schedule. So we're going to start. Let's switch to our black. We're going to have our start, which is 0. And we're going to move to the ones that don't have any precedence relations, which in this example is only A. So A is task of 3. All right, we have to do A before B, C, and well, let's go ahead and draw our B is 4. And then we have C is 7. All right, now we move along and we have to do B and C before we do D. So let's draw an arrow from B and an arrow from C before we do D, which is 6. We have to do D before we do E. So D to E E is 5. All right, and then we have to do E before we do F and G. So let's move down this way since we're running out of space. So E is before F, which is 5, and G, which is 4. And then once we've finished with everything, we can move on to our end, which is 0. So now let's take this whole graph and we're going to start scheduling with our 3 processors. So the only thing that's eligible right now is A. So A is 3. We're going to start right here with A. All right, well, these people can't do anything, so we're going to go ahead and put some idle time in right here. We have to start A, we move along, and then we finish A. So we can circle B or C. Now that we've circled B or C, we want to do B first and then C. So let's put B right here, which is 4 units of time. And we want to do C, which is 7 units of time. All right. Well, we go ahead and start these. We can't work on anything else. So this right here is actually also idle time. We're moving along. We get right here and now we finish B, but we can't do anything until we finish C2. So we're going to move along. We have some more idle time, Cross both of those out once we finish C, and we can circle D. So now somebody can start working on D. So let's put D right here. All right, now that we have D, we started D, we move along. Nobody can be working on anything else yet until we finish D. So all of this is idle time and all of this is idle time. We finish D, we go to E. So now we have E is 5. All right, and this is our E. We're running out of space here. All right, we start E, we move along, and then we finish E. So all of this, again, is more idle time. All right, once we finish E, we could do F or G at the same time. So we'll put F right here, which is I'm going to write the number here since we ran out of space. And then we can start G with the other one, which is 4. All right, so we're going to finish F before we finish G. We're going to move along. All right, this right here is also idle time. We have 1 hour or 1 unit of idle time here. When we get to the very end, so this was 21, 22, plus 4 is, we're at 26 right out here. So our finishing time for this example is 26. And we have a whole bunch of idle time, so we can count up and add up all the idle time, and that'll give us our idle time. But let's take a look at this example. So we had 3 processors, but did processor 3 do anything? Did they really? They didn't do much. So we saved a little bit of time by having the second processor, but it really didn't help having that third processor because they just got paid to sit around and do nothing. This is where it's very helpful to make sure we have an optimal amount of time for the number of processes and the precedence relations that we need to do for this chapter.